let's get going with the idea of just exactly what limits are. So for this next section here, the idea of limits is what we're going to concentrate on. So let's talk about some learning objectives. First of all, I want to understand what calculus is and how it compares to pre-calculus. And then I want to understand that the tangent line and the area problems are basic to calculus. These ideas bring us to the whole idea of just exactly what a limit is. So, just what is calculus? Well, I like to think of calculus as, or is, the mathematics of change. That's really, I think, a good way to think of calculus. Whereas algebra and pre-calc these both are the mathematics of statics. Statics making reference to things that are not changing. So let's explore this idea a little bit more here. Now in pre-calculus, you can measure the slope of a line. That's static. Whereas in calculus, is required to actually measure the slope of a curve. So here we go. Let's start off with just some function, x, y, some linear function, doesn't really matter what it is. I'm going to say f of x equals mx plus b, where m, I want to measure the slope of the line. Well, I can use algebra techniques from that. Find 2 points, take a look at delta y over delta x, and once I find that slope, the slope is constant, not changing throughout this line. Now, where you are on the line may be changing, but the slope is not changing. That's what I mean by the slope of the line being static. Now, on the other hand, let's suppose I have some curve. And let's just call this g of x. Well, what's it mean to have a slope of a curve? Well, at this point right here, I could measure the rate that I am increasing. But over here, the rate's different because I'm actually decreasing. So the concept of a slope, as it translates to a curve, is constantly changing. Hence, it's dynamic. That is what I mean by algebra and pre-calculus measure statics, and calculus is required to actually measure the dynamic change of things, the instantaneous change in position or instantaneous change of the slope here. So as an example, the position of an object, static, can be measured with pre-calculus or algebra techniques. Whereas if we're going to start talking about velocity, then we need calculus for. Now, right away you may be thinking, no, wait a minute, I've done velocity problems in pre-calculus and in algebra. Well, that's true, but what you've done in pre-calculus and algebra is you've used a calculus result. You may have been given some function and saying this is a velocity function, but where did that function come from? It came from a calculus process that gave it to you. So let's think for a moment here. A velocity is the rate of change in position. So how quickly are you changing where you are? That's velocity. Now, likewise, acceleration is the rate of change of velocity. So acceleration is how quickly are you changing your velocity. Are you speeding up? Are you slowing down? Are you constantly speeding up? Or are you fluctuating your velocity? That's what acceleration is. Now, in algebra and pre-calculus, like I said earlier, we often use the calculus results. But in a nutshell, this type of thing is what we need calculus for. Position functions we can do with algebra or pre-calculus. But we start talking about the rates of change of position. Again, that is dynamic. It's not static. Hence, we need a calculus techniques. And like I said earlier, very common back in algebra and pre-calculus, you were given functions that represented velocity or acceleration, but you're never told where they came from because they were actually a calculus result.